Okay, that's wonderful. And I'm recording this meeting. Okay, so that is actually what a quadratic function is. So basically, a quadratic function is any function with a degree 2. Is that okay? Say this is A. You're going to pardon my handwriting because I'm just using a laptop, using a mouse. Right. Are you able to visualize what I'm writing here? This is f of x is equals to a x to the power 2 plus bx plus c. Hello? Okay, now we are good. So a quadratic function is any function that has got the highest degree of 2. So the degree is this power of 2. So how do we come up with roots of such an equation? How do we solve for a quadratic equation? So in this case, A, B, and C, these are members of a real set. Are members of a real set where x is just a variable. So in this case, what we have here is a quadratic function. A, B, and C can be any number that is real. And we can solve for this quadratic equation. And whenever we solve for this quadratic equation, what we're just simply trying to do is we're simply trying to solve this f of x is equals to 0. That's what we're trying to solve when we're trying to find the roots of f of x. So this is basically what we are trying to do, to find the roots of this. So whenever we want to find the roots, there are certain conditions that not really condition, but outcomes that would come. We would have A, this is just a point, we would have equal roots. So equal roots. This is when the value of this guy, since the highest power of x is 2, it means whatever we are going to do when we solve, we'll get 2 solutions for x. 2 solutions for x, x1 and x2, which are going to be values of x at which point f of x is going to be equals to 0 whenever we replace. So when we say equal roots, it means those roots are equal. Say one of the root is x1 and the other root is x2. So it means x1 and x2, x1 and x0 rather. Let's just say x0. That kind of thing there. x1 and x0 are equal. Then the second outcome would be when they are distinct. Distinct roots. It means x1 is not equal to x0. Are we okay? Alemba pabodi or many alemba both. And you may as well need to turn off your mic.
Of x is equal to the root of x.
So when you have distinct roots, it means the value of x1, so assume your roots of f of x is equals to 0 where x1 and x0. So when you have distinct roots, it means x1 is not equal to x0. You have 2 different roots. And there is another case when the roots are what? Are complex. complex conjugates. This you will see. When the roots are complex
I'm going
conjugates,
to
so
tool.
it means x1 is equals to the conjugate of x1 as well. So x naught would be the conjugate with an asterisk there. Where is that? x1 is the conjugate of x2, or x2 is the conjugate of x1. In this other case, we're saying x naught. So before we could even go further into solving, I just wanted us to get these few points. So before we even go to doing any of the questions, am I low on everyone, or is it just Master's Band speakers that are not okay? Or are you all able to get me there?
Yeah, we're able to get you, but we're a bit low. Like,
I'm a
don't.
bit low.
Yeah.
Okay, let me try to speak up. Is this fine? Are you able to get me now?
Yes, sir.
Okay, that's wonderful. Then let us continue. So, now we have this form of an equation. Now let us try to get through to finding the roots of this guy. Just try to do this. Finding the roots of f of x is equals to a x squared plus bx plus c. So for us to find the roots, we have to equate f of x to 0. So in the end, what we'd have is x squared plus bx plus c is equals to 0. So in order for us to find, let us make sure that the coefficient of x to the power 2 is just 1. So we are going to divide throughout by a. So that when we divide throughout by a, what we would just have is x squared plus b over a x plus c over a is equals to 0. Then we want to solve this with the method completing the square. So let's see, since we want to complete the square, let's divide this b part by 2, so that in the end we might have something that looks like x plus b over 2a squared minus b over 2a, the whole lot of this is also what? Squared, then plus c over a, this is equals to 0. Are we all clear on how we've come up with this? Silence
Yes, sir.
means we are together. Okay, so if you want, you can expand this and add it to this. You end up with this very equation that we have on the top there. I might need to clear this other part. I need to clear this part so that we may use just one board, because I don't think I'll need to be going back and forth now. So you might need to remember those outcomes. So this guy, when we expand this guy, just okay, let's turn off this mic. Cornelius Banda, please turn off the mic next time when joining. Okay, so is b over 2a, the whole lot of this squared, minus, here would have b squared over 4a squared plus c over a is equals to 0. So let's combine those two guys so that we have x plus b over 2a squared. When we combine these two, we would have 4a, that would be squared there, it's a plus here, over, this will be b squared minus b squared rather. Oh no, oh yes, minus b squared over 4a c is equals to 0. So we'll just take this to the other side so that we remain with x plus b over 2a, the whole lot of this squared, is equals to b squared minus 4ac over 4a squared. We want to get rid of this power 2 here, so that this side we just have x, we just have x since we are solving for x. So we are going to square both sides. We'll square this side, which is the same as raising both sides to the power half. Are we okay? So that this and that cancels. That and that, when that cancels, so that when we compute this, we would have ax over 2a is equals to, since the root, when you square root something, whatever comes out after operating the square root on any given number would be either a positive, not either, would be both a positive and a negative number. So the results would give us plus or minus whatever is in here. So the square root of 4 is 2, and the square root of a squared is just a. So in the end, we would have plus or minus the root of b squared minus 4ac, the whole root of this over 2a. So that we can just get in this guy and send it to the other side. Just try to see if I can get the next board. So that we would have x is equals to, okay, I have a warning here. It says that the meeting will be ending in less than 10 minutes. So when the meeting ends, just to rejoin using the same link, okay? Hope you understood that. So that this would be minus, what did we have here? We had x is equals to minus b over 2a plus or minus the root of b squared minus 4ac over 2a. The denominators are the same, so we may as well just write it as a mixed fraction or a single fraction, so to say. Minus 4ac over 2a. Over 2a. Okay, real man, I've seen your hand up. Come in. So this is what actually would result into the solution of x. So having this equation, oh sorry, since we've cleared that board, we have that equation saying f of x is equals to a x squared plus bx plus c. Having this equation, we can find the root of this equation. Knowing the value of a, b, and c, we'll just have to be replacing them in here, which would result into us getting two of those values. And our point of interest would be this guy here, the one in the square root. This is what we actually call the discriminant. So whatever outcome we have in these guys, b squared minus 4ac. Whenever we solve for this, whatever would come out, actually, what is going to determine whether we are going to have whether we are going to have distinct roots or we are going to have complex or equal roots. This guy is the one that is going to tell us all that information. Those three I outlined there. This guy is the one that is going to tell us. Whenever this is positive, whatever is out of will be real. If this is equals to 0, then we are going to have equal roots. So if let's say this is equals to 10. So this is discriminant. So when D when D is equals to 0, you have equal roots. Equal roots. We have equal roots when D is greater than 0. When D is greater than 0, you have distinct roots. They will be real and distinct. When D is less than 0, you would have complex roots, complex conjugates. When I say complex, you will have complex roots. Okay, real man, you had your hand up. Are you still there? Real man has left the group, but real man had their hand up. So, any question up to this point before we go into solving one or two questions from a tutorial sheet that I was sent? Any question from all the way from here, coming to this part, going through to this last part until we get this part of the solution? Okay, assume that is clear. Okay, so I think for now, let's try to do one or two questions from the tutorial sheet. But since this meeting is just about to end in 3 minutes, so I would advise we just cancel this meeting and start a fresh one using the same link that you used to join this meeting. Are we together?
Yes.
Yes. So I'm going to end this meeting shortly, very shortly here. Just quickly join into the same link so that we can solve one or two questions from the tutorial sheet. Okay?
Okay.
Wonderful.
Okay.
Stopping to share. Then I'm ending the